You think your eyes show you the world. They don't. Your eyes send your brain roughly 10 million bits of information every second. Your brain consciously processes about 50 of them. Everything else, the room around you, the peripheral detail, the texture of what you're looking at right now, your brain invented. It built a model, filled in the gaps, and handed it to you as reality. And you believed it. You always do. Here's what's actually happening when you open your eyes. Your eyes are not cameras. A camera captures what's there and sends it somewhere to be processed. Your visual system does not work that way, at all. Your eyes capture a narrow, surprisingly low-resolution stream of light information, sharp only in a small central region called the fovea, blurry and incomplete everywhere else. What your brain receives from your eyes is frankly not enough to build the rich, detailed, stable world you experience. So your brain doesn't wait for enough information. It doesn't sit patiently while your eyes scan the room and build a picture piece by piece. Instead, it does something far stranger. It guesses. Your brain runs a constant real-time simulation of what the world probably looks like, based on everything it has ever seen before. Before your eyes even finish sending their signal, your brain has already predicted what's there. The visual input from your eyes creates your experience of the world. It corrects your brain's prediction of it. What you see is not the world, it's your brain's best guess at the world, updated slightly by incoming data. Neuroscientists call this predictive coding. Once you understand it, you cannot look at anything the same way again. In 2013, neuroscientist Carl Friston at University College London described the brain as a prediction machine, an organ that has never perceived reality. Instead, it perpetually generates a model of what it expects the world to be, compares that model against incoming sensory data, and updates only when something doesn't match. The world your eyes report. It's the world your brain expected corrected for surprises. Think about what that means. Every room you've ever walked into, every face you've ever recognized, every object you've ever reached for without looking, your brain had already built all of it before your eyes. You were living inside a prediction. You have always been living inside a prediction. But here's what's strange. The prediction isn't just fast. It's dominant. When your brain's model of reality conflicts with what your eyes actually report, your brain often wins. It's the incoming data. It keeps the prediction and discards the correction. This is not a bug. This is the system working exactly as designed. In a world where processing speed meant survival, a brain that could act on a prediction was faster than a brain that waited for confirmation. Have time to verify. They had time to run. But here's what that costs you. There is a hole in your vision right now, a place where your eye sends no information to your brain at all, where the optic nerve connects to the retina, and there are simply no photoreceptors. It's called the blind spot. Small. In your visual field, the gap is roughly the size of 17 full moons stacked side by side. You have never seen it. Not because you can't. You can find it right now with a simple test. But in every waking moment of your entire life, your brain has quietly painted surrounding visual information, made a prediction about what was probably in the gap, and filled it in, seamlessly, instantly, without asking, and it got it wrong sometimes. The blind spot is the most obvious example, but it is nowhere near the most dramatic one. Neurologists Daniel Simons and Christopher Chabries at Harvard ran an experiment that produced one of the most uncomfortable findings in all of cognitive science. They showed participants a video of two teams passing basketballs and asked them to count the passes made by one team. About halfway through the video, walked slowly through the middle of the seam, stopped, thumped their chest, and walked off. Half the participants didn't see it, not because they weren't looking. They were staring at the screen. Not because the gorilla was subtle, it was in plain sight for 9 full seconds. But their brain had been given to count the passes, and it had built a model of what was relevant. The gorilla wasn't in the model, so the brain didn't process it, didn't flag it, didn't show it to them. They weren't distracted. They were doing exactly what their brains were designed to do, filtering out everything that didn't match the prediction. The gorilla was real. Not. And this happens to you every single day. The version of this room you are experiencing right now is missing things. Real things. Things that are physically present in your environment that your brain has decided are not relevant to its current model and has therefore quietly removed from your experience. You never know what they are. But it goes even deeper than that. Take color. You probably think of color as a property of the world, something that exists out there, in objects, waiting to be seen. It isn't. Color does not exist outside your brain. What exists outside? Wavelengths of light bouncing off surfaces. Those wavelengths have no color. They have no appearance at all. Color is something your brain creates. When light hits your retina, specialized cells called cone cells respond to different wavelengths. Your brain then takes those signals and generates an experience, red, blue, green, yellow, that has no physical existence anywhere in the external world. The apple isn't red. Your brain decided to call the wavelengths bouncing off it red. And it made that decision based on how your specific vision, specific genetics, and your specific history of seeing processes that particular frequency of light. Which means two people looking at the same apple are not seeing the same color. In 2015, a photograph of a dress tore the internet apart. Some people saw it as white and gold. Both groups were looking at the same image on the same screen. Their brains, using different assumptions about lighting and context, built genuinely different colors from the same data. Neither version was the real one, because there was no real one. The real dress had wavelengths. have ever loved, every argument you have ever had, and every moment you were absolutely certain you were right. All of it built